Hello guys, today we're doing LeetCode question 15, which is free sum. This is a medium question. The question is, given an integer array nums, return all the triplets, nums I, nums j, and nums k, such that I does not equal to j, I does not equal to k, and j does not equal to k. And nums I plus num j plus num k is equal to 0. Notice that the solution set must not contain duplicate triplets. So example 1, nums is equal to -1, 0, 1, 2, -1, 4 as an array. The output is an array of arrays. The first array is -1, -1, 2, -1, 0, and 1. So they're not the same, the different triplets. Explanation, nums 0, nums 1, nums 2 is equal to -1 plus 0 plus 1, which is equal to 0. Nums 1 plus nums 2 plus nums 4 is equal to 0 plus 1 plus -1, which is equal to 0. Nums 0 plus nums 3 plus nums 4, -1 plus 2 plus -1 is equal to 0. The distinct triplets are -1, 0, 1, -1, -1, 2, -1, 0, 1. Okay, these ones are only, these two are the same, got the same three triplets, so -1, 0, and 1, and 0, and 1, -1. That's why there's only 1 here. So the way we'll do this is, we're gonna use 2 pointers. We're gonna first we're gonna sort the array first. Then we're gonna loop through the array at I value. We're gonna have a j pointer to have the start of the array following I, and the k pointer to have the end of the array. And then since it's sorted, we know it's in size order, so we'll check if it's equal to 0, or if it is, then we add that to the array, and we increment j and decrement k, yeah. Otherwise, if it's smaller, then we know we have to get a bigger number, so we increment j. And if it's bigger than 0, we know we have to get a smaller number, so we decrement k. The reason I'm going to mention again is because it is in size order. So let me show you an example on the whiteboard. So this is our given array. So the first thing we do is we're going to sort it. So this sorted array would become now -1, -1, 0, 1, 2, 4. So let's rub the previous array out first. Okay. So that's our sorted array. Now, we're going to loop through the array. We're going to have I, which is first going to be equal to 0. J will be equal to I plus 1, so j will be equal to 1. And k will be equal to the array.length -1, so that will be 5. So k is equal to 5. So I'm going to use different colors. Black for I, so I'm going to show here. Black for I, red for j, and blue for k. So we're first going to check I. I is -1. Then we're going to get j, which is also -1. And we're going to get k, which is 4. We're going to check. Is j plus k, I plus j plus k equal to 0? So -1 plus -1 plus 4 is 2. So that is bigger than 0. So we know that we can make the number smaller by decrementing k, because again it's in size order, so k will be the biggest element, and any numbers below that will be smaller. So we'll decrement k. So now k will be 4, index value 4. So we are at 2 here. Now -1 plus -1 plus 2, is that equal to 0? Yes, it is. So we're going to push that into our new array. So we're going to create an array here. Array. We're going to push as an array I and j and k, which will be -1, -1, and 2. Okay. Now that we found a value, we increment j and decrement k, as we can't have the same values. So if we just increment 1, we're going to have the same value, which means the other value would have to be the same as well. So we're going to increment both until they are not the same value. So j plus 1 is equal to 2, which is 0, and that's not the same value. So we set j to 2. K minus 1, which was 4, is now equal to 1. That's not the same value, so we leave it as that. So k is now 3. We're going to check. Is -1 plus 0 plus 1 equal to 0? Yes, it is. So we're going to push that as well in the array. So -1, 0, and 1. Then we increment, and again, now they overwrite each other. So we're going to break that while loop, and we're going to go into the next I iteration. Okay, now I is equal to -1. So that is the same value. Since we can't use the same value again, we're going to increment I by 2, which will be now 2, which is 0. And I'm not going to continue from here because everything is bigger than 0, which means we can't create something that's equal to 0. So this is our final array. And so we're going to have to return this array here as a result. Let me show you how it's done. So the first thing we do is sort our array. So we do nums.sort. For each value, we set smallest to largest. Then we loop through our array. So for let I is equal to 0, as long as it's smaller than nums.length -2, because we're going to have 2 pointers after it, we increment it. Then, as we can't use the same number twice, we check if I is bigger than 0, because if it is 0, we haven't looped it yet. If I is bigger than 0 and nums I is equal to nums I plus 1, then we increment I. In fact, we just continue to the next loop. Then we set the j value as I plus 1, we set the k value as nums.length -1. Now we loop through j and k as long as j is smaller than k. Because if they're the same, we can't use the same number twice, as there's only one of that value within that array. Next, we get the sum. So let sum is equal to nums i plus nums j plus nums k. And we check if the sum is smaller than 0, we know we're going to need a bigger number to get to 0, so we increment j. As we're sorting it in size order, we know the number above next after j will be bigger, so increment j. We do the same with if sum is bigger than 0, we need to get a smaller number, so we decrement k. Else we know it is 0, so we push into into the array. I forgot to create an array. So we create here an array, and then we push into the array the values in order. So nums I, nums j, and nums k. And then, as we can't use the same values twice again, we have to check that j, the value at j, is not equal to value at j plus 1. So if it is, we have to increment it, j. We do the same with k. So while nums k is equal to nums k minus 1, then we decrement k, and then we increment the decrement one more time, because we have to, even if they're not the same values, you increment to go to the next value. And if they are the same values, we only go to the next value is not the same. So when we get to the last value, if it is the same, the next value won't be the same, so it won't increment, but we still need to increment, so we increment again one more time. And then, as a result, we return the array. Let's see if that passes. Serial list is not valid for return type list integer. List integer. -1, 0, -1 is not valid for value type return list integer. Okay, so we push these as an array. Now let's run. Okay, -1, -1, and 2. Nums I is equal to this is nums I -1, because we've already checked the previous value. So if nums 1 is equal to 0, we continue. So now let's run. That should pass. Perfect. Let's submit. As you can see, this is the fastest time complexity. We could also improve this by removing the sum here, reduce some space. Just checking here if nums I, nums j, nums k is bigger than 0. But we'll keep it as this for now. This is time complexity of O n squared, as we're looping through the array, and then for each value, we loop through the array again. And this is a time complexity of O(n), as we're again storing the whole array. Thanks for watching.